Hi, my name is Dongjae Lee, and this is Lab 4 Rope Physics Spring Mass Lab presentation. The objective of the experiment was to analyze the motion of spring mass that oscillates in the shape of an arc. The result turned out to be that the predicted motion of mass matched the pattern received from the tracker, and the spring mass system fulfills the energy principle. So here are the two main fundamental physics principles that I like to talk about, which first one is momentum principle, as we know from previous labs. The second one is what's new and what's important, which is called the energy principle. This states that the change in total energy is equal to the addition of delta kinetic energy and delta gravitational potential energy and delta spring potential energy. In this lab, I'm going to prove that the change in total energy was zero, since there were no external forces that were playing part in the experiment. So let's take a look at the tracker file that I've made here. The origin was set as given in video lecture, along with the distance, which is 0.7 meters in between these 2 points here. So after running the tracker file, I was able to extract the time, x, and y position data to plug it into the CSV file that's going to be needed in analyzing our VPython model. So, using fundamental principles and a couple of the equations, I'm going to explain to you how I came up with the VPython code. Setting up the initial conditions, the ball mass 0.4 kilogram, and the ball position, which is the data that I was be able to extract from tracker when time is 0. So gravity constant is 9.8 newtons, and to find out Ks, which is spring constant, L0, which is relaxed length, and L, stretch length, I needed to use a couple of the principles to solve for those numbers, which by combining these two equations for period and omega, I was able to solve for a spring constant, which is Ks, which turned out to be 6.88 newtons after plugging in all the numbers. And using Newton's second principle, I was able to set an equation where it states that force of tension in spring is equal to spring force, which is equal to Hooke's law, spring constant times L minus L0, which we're going to use variable S for that, which, because the tension was involved, is pretty much equal to mg. So plugging out all the numbers, I was able to find that the S is 0.572 meters. Thus, the relaxed length of the spring, which when subtracted from the initial length, 0.7 meters, as we remember from my tracker, turned out to be 0.128 meters. So now I plug all these numbers into this chunk of the code, along with all the necessary information that I need to plug in, which are the equations for kinetic energy and two different potential energies explained in the fundamental principle. Kinetic energy is equal to 1/2 mv squared. Gravitational potential energy is mgh, and spring potential energy, as we know, is equal to 1/2 times spring constant times s squared, which again s represents L minus L0. So after plugging in all these equations along with the time constraint and while loop, which I know this number from tracker file, I'm going to run a module to see what happens, and this is going to take a little while. Excuse me. And running the model, we're able to see this animated model of the mass. The blue arrow here represents the spring force, and the black arrow here represents the gravitational force, which we can see they balance out to create this systematic and symmetric traces of pattern. And this shows that because there was no deviation to this pattern, now we are able to realize that there was no external forces that were playing part in this experimentation. Thus, the first energy principle is satisfied. The constant oscillation and no external forces, again, answers the question number 1. The second question, using the data you have trained in tracker, compare the oscillation of x position and oscillation of y position. So these are the data that I've gained from tracker file. So I've organized the x position data and y position data to find out the different periods, which was 1.7 and 1.5 seconds for each, which there were 0.2 seconds of difference. And the reason why there was a difference in time like this is because the oscillation was an elliptical shape. And why do they have a different period of oscillation? Here's a reason why. Because motion in x direction was affected by gravity and length of spring, whereas motion in y direction was affected by the stiffness of spring and the mass of the spring, which are different causation of forces. Thank you for listening to my presentation.